Okay, so these notes are over variation functions, and we're going to focus on direct variation functions and joint variation functions. So, y varies directly as x if there is some non-zero constant k such that y equals k times x, which that's the really important equation we need, and k is called the constant of variation. K is the same idea as slope. Okay, so it's your change. All right, so that's for direct variation. So your equation is y equals k times x for direct variation. So if y varies directly as x and y equals negative 15 when x equals 5, we want to find y when x equals 3. So our first step is we need to identify what all goes together. So y equals negative 15 when x equals 5, those two go together. Y only equals negative 15 when x equals 5. And then we're going to be finding y when x equals 3, so those will go together as well. It's a direct variation problem, which means the equation that we're going to be using is y, I just changed pens and it's still not working, y equals k times x. Well, given this very first sentence, we know if y is negative 15, that equals k times when x is 5. So we really have negative 15 equals 5k. And we can solve for k really quick and easy by dividing by 5. So we get that k equals negative 3. So now instead of our direct variation equation being y equals k times x, we can say that it's y equals negative 3 times x. And we can solve for y given that x is 3 now. So y equals negative 3 times 3. So we get that y equals negative 9. So really what we did here is we solved for k and then rewrote our direct variation equation with k and then plugged in whatever variable we needed. So another example, if y varies directly as x and y equals 12 when x equals negative 3, so those two go together, find y when x equals 7. So what we can do here, it's direct variation, so our equation is y equals k times x. Well, the equation, the two that go together, and we have both, is this first sentence right here, y equals 12 when x equals negative 3, so we can solve for k. So 12 equals k times negative 3. So to solve for k, we're going to divide both sides by negative 3, and we get that k equals negative 4. So now our equation is y equals negative 4 times x. And now we can find y when x equals 7. So y equals negative 4 times 7. So we get that y equals negative 28. All right, next up we have joint variation. So y varies jointly as x and z if there are some non-zero constant k such that y equals k times x times z. So you're going to treat this very similar to direct variation. We're just adding another variable z in there. So y equals k times x times z. So suppose y varies jointly as x and z. We want to find y when x equals 10 and z equals 5 if y equals 12 when x equals 3 and z equals 8. So the equation you need to start with is the one that you have all three parts y, x, and z in. So we're actually going to use this second piece of information first. So that's going to be our step 1. So our equation is y equals k times x times z. Well, y is 12, and that equals k times 3 times 8, which means 12 equals 24k. And dividing by 24, we get that k equals 1/2. So now our equation is y equals 1/2 xz. So the second part, or actually the first part listed, which is going to be our second part of our equation, is we're going to find y when x equals 10 and z equals 5. So y equals 1/2, x is 10, times 0 is 5. So y equals 1/2 times 50. So y equals 25. And the last example for joint variation. Suppose y varies jointly as x and z. Find y when x equals 3 and z equals 2 if y equals 11 when x equals 5 and z equals 22. These three go together and we have all three parts. So given that we know y, x, and z, we're going to be able to solve for k. So y equals kxz, which means 11 equals k times 5 times 22. So 11 equals 110k. And then we divide by 110. So we get that k equals 1/10. So now our equation is y equals 1/10 x times z. And we can use the other part of our equation to plug in and solve for y now. So we're going to find y when x equals 3 and z equals 2. So y equals 1/10 times 3 times 2. So y equals 1/10 times 6. So y equals 6/10, which is really 3/5.